So here we have a linearly polarized light which is passing through two polarizers. The first one is at 45 degree with respect to the original axis of polarization, and the second is at 90 degree to the original axis of polarization. And we are asked to find the fraction of original intensity that is passing through the last polarizer. So here we can make use of Malus law, which states that I1 intensity after passing through the polarizer is equal to original intensity I0 times cos square theta. Here theta is the angle between the light's polarization direction and the axis of polarizer. So theta is equal to 45 degree in the first case, because the angle made by the first polarizer with respect to the original axis of polarization of light is 45 degree. So that means after passing through the first polarizer, the intensity I1 is equal to I0 cos square 45 degree. So this is equal to I0 by 2. Now the light's alignment is also changed. Light is aligned now along the axis of first polarizer. That means the angle between the light's polarization direction and the second polarizer is now no longer 90 degree, but it is now theta 1 now is 90 minus 45 is equal to 45 degree. So this is the angle between light's polarization direction and second polarizer after passing through the first polarizer. So that means I2 is equal to, that is the intensity after passing through second polarizer, this is equal to I1 cos square theta 1. This is equal to I0 by 2 cos square 45 degree equal to I0 by 4. So intensity is reduced 1 by 4 times, which means the correct option is option B.